Okay, so we are like 1.5 minutes earlier, but I think we can get started. So the next talk will be presented by Jeff Hammond. He's a principal engineer at NVIDIA, based in Helsinki, Finland. He has advanced the MPI standard and its ecosystem for over a decade, including the development of MPI-3 RMA and its use as a backend for global arrays and OpenSMEM, as well as initiating the large count initiative and leading the ABI working group in the MPI forum. He has a PhD in chemistry from the University of Chicago and has contributed to the development of NWChem for almost last 20 years. Many of you in the community must be knowing him. So today his talk will be a little bit different. He will focus on MPI application, binary interface standardization, and a new initiative which is leading. Jeff, are you ready?
I hope so.
Give us just 1 sec here while I pull you up on the big screen.
Okay.
And you should be able to go ahead and share your screen now.
Yeah. We can see your screen and
So many pop-ups. Okay. All right. I can't really. I'll try to keep. I'm just using a laptop, not 2 monitors, and that's a pain here. Okay. So I'm going to talk about application binary interface. I have no pictures and almost no performance results. So, but I think this is an extremely important topic that a lot of people care a lot about. I got interested in it kind of because I like suffering, and because people thought it was an interesting, hard problem. And it turns out a lot of people are really excited about this. So I hope you are too. I put my email on here because this is a very important thing to get right. This isn't research. If you make an error in your research, life goes on. The goal for this project is to standardize something in the MPI forum that will last ideally 20 years, maybe more. So if you see even the slightest hint that something is not right and we've missed it, please tell me. It's really important. I want to know. The reason we want as many eyes on this as possible is because there's a lot of edges, and we want everybody's feedback. So I'm presenting on behalf of both the ABI working group, which I co-chair with Quincy Kozoil of AWS, and my co-authors of a paper that is about this topic that is going to be at Euro MPI in a couple weeks. It'll be on archive tomorrow. I'll talk more about this in a second. Okay, what problem are we solving? So if you're not already familiar with this problem, you may know in practice that if you build with OpenMPI, you need to run with OpenMPI. If you build with MVPitch, you need to run with MVPitch. Or, and this is important in this context, you can build with MVPitch and run with MPitch or Intel MPI, for example. And the reason that works is special. There's nothing in the MPI standard that says that works, but it does, and that's at the core of this topic. But ultimately, what we are trying to solve is to create a world where MPI becomes something that you build against MPI. You don't build against an MPI implementation. And that means if you build against MPI generically, you can use anybody's implementation. You can ship binaries that work everywhere. You can download Linux binaries from package managers, SPAC, ISV codes, etc. And it becomes something where MPI is standard, not just in the sense that there's a book and there's code that you write and it works, but rather it's a standard at the object level, at the library, at the binary level. So that's really what this is all about. So what's the difference? If you're not familiar with the technical aspect of this problem, an API is what you know in MPI. So the MPI beatcast call takes some generic C arguments, and it takes an MPI data type and an MPI com argument. And all you know is those are C types that get defined, and you don't get to introspect them. they're just opaque. That's what the standard says. They fulfill some basic criteria, but they're opaque. Of course, ABI really means what is the actual binary or the origin of the binary pattern by which those things are defined in an implementation. So if you look at the OpenMPI header, you see typedef struct OMPI data type T. So that's what's called an incomplete struct pointer. It's a very important concept. Even though it says struct, there's no struct definition anywhere. It's an incomplete struct. And what that means is this is a type, it's a pointer, but the compiler knows that this is a pointer of this type, and it can distinguish it from other types. And that's a property we like. It'll give us type safety. But there are some trade-offs. On the other hand, mpitch, and of course, anytime in this conversation I say mpitch, I mean mvpitch from the standpoint of the definition of the ABI, because mvpitch is binary compatible with mpitch, like Intel MPI and Cray MPI. You can find the details out later. But they use handles as ints. So that has some advantages for language interoperability, but disadvantages that you can pass a group to a com and a com to a data type and all sorts of things and not get caught. And I have seen user code that does such things, and magically they work because they're just typedef int in mpitch, and then someday they compile with OpenMPI and it doesn't work. There are other things in an ABI, the names of shared objects, how shared objects are versioned, calling conventions. This is deep stuff. It really does matter in practice, but it is extremely well understood in the communities that build packages, the Linux community, the people who work on apt or Fedora or whatever it is, they understand this stuff. The thing that the MPI community must solve is the other stuff. What are our handles what are our handles made of? What are the types of our MPI integers? What are the constants? And that's the job that we've been doing for, I guess, a year or two now. So the status quo, there is the mpitch family of ABIs. You can find out in the link below the details exactly of that. And then there's the OpenMPI family, which includes NVIDIA's HPCX, Amazon MPI, IBM Spectrum MPI, and there's others here, but these are just the ones that I was looking at. The first family is a formal family. There was a demand a few years ago because Intel MPI was used for a lot of ISV codes, meaning like commercial, ANSYS, Fluent, whatever, LS Dyna, things that people wanted to just work. They were built with Intel MPI for x86 systems, and other MPI implementations wanted the ability to be compatible. So mpitch changed its ABI to match Intel MPI, and through that, then mpitch derivatives became compatible with Intel MPI, and that's the origin of this initiative. And you can see this. You can, diff the header files or look at them, and you'll see this history. OpenMPI has an ABI design, which I described a little bit earlier, that doesn't change. The implementation of that design may change. OpenMPI does not give any specific guarantee about ABI compatibility. They focus on some other things. They focus on some stuff, compatibility of other kinds that matters in the container space. But they don't guarantee anything. But of course, you might get lucky a lot of the time. And these are just choices that people make. They're both fully compliant with the MPI standard from an API perspective, regardless of what they do with their ABI compatible or not. But we know now from the success of the mpitch ABI initiative and the way people have used it in the community, that this is a valuable property. So standardizing the ABI at the forum level really is about uniting all the clans, not just having two clans. So why do we care? Well, I mean, it should be obvious. We have a lot of third-party language software, Python, Julia, Rust, that would really like this. That's actually the original motivation for me to work on it. Is the Python people, Julia people said basically, this is the only thing I want from MPI. I don't want anything else. I don't want any new functions. I just want an ABI so I can stop building twice or more. Package people, same situation. The tools, all the tools have to be built against all the ABIs because they interface, when you do a DL open or a LD preload, you are interacting at the binary level with an implementation. So you have to know what those handles are. Containers. This is the one at the end of the day. I don't use containers. I don't want to say it, but I don't care about containers because I don't use them. But a lot of people do. They're really important to a lot of people. This is actually what's going to get us over the finish line. The container people are very important. This is a huge challenge that we want to be successful with. And so the forum is, very responsive to that user community. And of course, many people in the forum don't have the same indifference that I do. It's actually a good thing for a lot of people out there in the community. Less important things are, people don't want to have to recompile PETSI twice. For example, they would like to just compile PETSI once against one MPI, and then test the implementations. But when you're dealing with a package of that size, building n times in CI can be annoying. You might ask, well, if this is so good, what took you so long? This has come up a lot. People have been talking about this problem for 20 years. Why didn't they solve it? Well, 10 years ago, more years ago, there was a lot of diversity in the HPC ecosystem. Having an ABI would not have been particularly useful when we had Itanium, IBM Power, DEC Alpha, RISC, SGI RISC, MIPS or Spark, all these different things. There weren't a lot of binary compatibility opportunities between anything in that era. It really wasn't until sort of Linux x86 took over, obviously, less than 20 years ago, but more than 10. The other thing that happened is the architectural reasons why ABI was overhead related to the ABI, those things are gone. So there's some people in the room like Brian Smith who know a great deal about Blue Gene MPI. There are things that were very expensive on Blue Gene. You would not want to do extra pointer indirection, extra branching, extra 64-bit integer multiplies if you didn't have to. And so there were known measured advantages of the MPitch ABI on that sort of a processor. And so changing to the OpenMPI design or adding another layer of indirection to be universal would not have been appealing. And so the fact is we don't have processors like that anymore, except in the GPUs, which is really not in scope here for reasons that we could talk about another time. So nowadays we have basically two ABIs. We have an ARM 64 and an x86 64 Linux ABI. So that covers more than 90% of the HPC world, and that means if you build those two binaries, you make a lot of people happy. And of course, the fact that there still is power and there is RISC-V, there's no reason not to do an ABI. They would like to get the same 2x advantage that everybody else would. It's just that there's now enough reuse of binaries across the HPC ecosystem to say, yeah, we're going to get a huge amount of value out of this in ways we wouldn't have, say, in 2005. So this is a paper. This DOI link does not work, but that's what they told me the DOI is going to be in a couple of weeks. I submitted archive this morning, my time. I guess it'll appear sometime after midnight, maybe Ithaca time. I don't know archive exactly. So if you go on archive and look for my name or any of our names, you'll see this paper if you want to read it tomorrow. So we wrote this paper. This will appear at EuroMPI in a couple of weeks. And I highlighted where everybody came from motivation-wise, because I wanted to show, the extent to which we had different types of stakeholders in the MPI community looking at this problem. And this is just the people who were willing to be subjected to writing the paper with me. There are plenty of others who've contributed who are not contributed to the effort, who are not on this specific paper. So we have here, people who think about containers, third-party languages, tools, the ABI abstraction layer, the first of which was built, well, not the first, but the first widely used one built by CEA. That proves, some of the ideas here are necessary and possible. Eric Schnetter also wrote one called MPI Trampoline. I wrote one. Anyways, so we also have Hui Zhao, who's essential in this effort because he built the MPitch prototype of the standard ABI. And through that, we have a great deal of evidence that what we're doing is going to work from a performance perspective. And it's also going to work from an ecosystem perspective. As you know, many implementations are based on MPitch in a large or small way. And knowing that MPitch has already prototyped this and has something that works demonstrates that, you know, if you're at Cray or the MVPitch team or at Intel and you're downstream of this, you're not going to get stuck with the bill to implement this. It should just be there. That's our expectation. So I want to give one very important disclaimer. I'm going to talk about this stuff, you know, as real as it can be. Some of the decisions we had extensive arguments and voted unanimously on design decisions. In other cases, we were debating within the last 24 hours very vigorously about what we were going to do, and we do not yet agree. The ABI proposal won't be read until September when I read it, and it will likely change. Okay, it will certainly change because people are not going to like everything that I wrote. And therefore, don't look at anything on these slides and say, that's the MPI 4.2 ABI. I'm ready for that. I'll start coding for it. This is not real until it's published. But you know, some things here are very, very close to real, others not so much. And so your feedback is still welcome, particularly on the things where there is still not consensus. Okay, the design we're going for. We are only going to look at 32 and 64-bit platforms. If you have DOS and you're running MPI, I'm sorry, that's your problem. Stop using DOS. If you have an exotic mainframe system or something else with 128-bit addressing or pointers, that's cool. I actually thought about that a great deal, including the ARM Cherry platform. The problem is we just don't know as an MPI community enough about those to standardize it. And frankly, it's niche. So we're going to stick to 32 and 64-bit platforms. We're going to standardize MPI AINT to the only C type that makes sense, which is int pointer. And that's just going to make it, bam, it's int pointer. It'll be the right size of the pointer, which it needs to be. MPI offset is going to be a 64-bit integer. I worked through this. I put it on my blog if you want to see my homework. We will not need 128-bit file offsets or even 65-bit file offsets for 30 years. And I had somebody who builds cloud file systems for a living fact check me on that. My math is conservative when I say we won't need 65 bits for 30 years. It turns out if you want to blow out your 64-bit offset budget today, the file storage media alone will cost $90 million, which is more money than most people spend on supercomputers, except perhaps Dan Stanzioni. So you can't afford to make an exa file that requires 65 bits, and therefore I don't have to worry about the ABI problem it causes. MPI count is 64 bits derived from the previous two. Handles, they will be like OpenMPI for type safety. That's the only type safe design, and it's a good one. However, we figured out how to do compile time constants within that design, which they have to be. Turns out OpenMPI's design, as great as it is, depends on link time constant resolution, which doesn't work on Windows, which, even though I don't personally care about Windows, represents an OS portability bottleneck that we're not going to burden the ABI with. Okay. We also came up with a Huffman code to encode information and a structure to all the handle constants. You don't have to use it. Turns out the table entries, there's only, I think the table fits into about 300 entries or less. I can't remember off the top of my head. It's in a Python script on GitHub. If you want to look at it, you can make a table, no problem. Or you can use a Huffman code if you think that's fun. One thing we debated a lot, but decided on is 0 is never going to be a legal handle, and that's to detect uninitialized data, which might be really good for tools and sanitizers. Be able to tell somebody, hey, I know you think you passed me an MPI communicator, but actually you didn't initialize it. Your code's bad. Throw an error. We also encoded the type sizes in fixed size type constant handle values, like MPitch does. Unfortunately, cint isn't actually a fixed size type. int32 is, MPI char, which is used in all the message rate benchmarks, is. So, we'll have a lot of the benefits of existing stuff. The integer constants, which don't really matter, they're all going to be in the negative space or powers of 2 if they have to be. But they're going to be globally unique, and this is going to be nice. So if you pass MPI any tag to an argument that accepts MPI any source, that's an error, but we'll now be able to detect that error and say you passed any tag to the source argument. And that's a much more specific error than just, hey, -47 isn't a valid rank. And you don't have to implement all this, but it's really nice to be able to detect bad programs with as much detail as possible. The types of people that make these errors need the most help. We're going to try to make that possible. Okay, so packaging, it's still going to be MPI.h. I think I want to put it in ABI subdirectory so that you can put that subdirectory on it and force it. There are pros and cons to this. I'm definitely interested in feedback. We may distribute a standard header from the MPI forum. This is kind of interesting from the standpoint of people who build containers. So there are people out there who want to build a container that contains an MPI dependent software, but never install MPI on their computer because they don't actually want to do anything with MPI. They don't want to run it. They just want to build their Docker file and then publish it. And if we're distributing a standard header and a standard SO that stubs, they can do that, and they don't have to build an MPI thing. We'll also expect shared object versioning to happen via the convention. MPI standard doesn't talk about operating system details, so we're just going to say follow the convention. Obviously, everybody's going to use Linux. They're going to use the convention. This is one I was chewing on earlier today, but the ABI is going to be versioned independent of the API, and we're going to start with 1.0. This is all up for debate if you don't like it. Obviously, like the standard convention, backwards compatible changes will increment the minor, incompatible will increment the major. I really hope we never have to do that. My goal is to make a backwards compatible ABI that lasts 20 years. Hopefully some of you in the room will be young enough to see whether or not I fail and then can make fun of me later at supercomputing if I do. But the goal is not to fail. Adding new functions doesn't change the ABI. I know that may not fit the standard convention in the GNU world, but there really isn't any impact on the MPI ABI that anyone cares about if we add new functions, and you can get that information from MPI get version. What we really want to version with the ABI is the stuff that's actually ABI sensitive, like the handles. And so, if we add a new handle type, MPI Q, which people are talking about, that'll be a minor because there's nothing incompatible about adding a handle type. We've got enough reserved space in the Huffman code to stick a lot of new stuff in there and not move anything. If we make some colossal screw up, we have to make an incompatible change. Obviously, we'll go to 2.0. Hopefully that never happens. There's some stuff with Fortran. Almost all of it is completely straightforward, easy. There are some nasty things with the handle conversions because of the horrible property of Fortran that integer is not fixed size. You can, with compiler flags, decide that integer will be either 4 or 8 bytes. There's no way for us to standardize the MPI fint type with that flexibility. All we can do is say, it's usually the size of a cint. We're going to assume that. And if you decide to do bad things with integer that don't match that, you have to deal with it. The alternative is to somehow remove these handle functions from the ABI, which then creates a different problem because people do actually use this, including in some of the client use cases like Julia. If you have insight on this, if you want to argue, please email me. You can join the Slack. We're having a fun time talking about this one. Most people don't care about Fortran because they complain, Fortran sucks. It doesn't have ABIs, modules, blah, blah, blah. It's not actually that bad. It's just that Fortran has some flexibility that C doesn't. And if, for those who aren't aware, no matter how we feel about Fortran users, I'm one of them, Fortran consumers of MPI are, last time we checked, the majority of all MPI users. So even if you're a computer scientist and you think Fortran is dumb, if you were in any way involved in building MPI for people to use, your users are more likely than not Fortran people. So we care. So how we're going to implement this, you can do a standalone implementation. We've got 3 different opportunities for that, including one that I wrote in order to understand how the stuff worked. The integrated option is the one that MPitch is prototyped. That's where you take an existing implementation and you bootstrap the API on top of it, or ABI on top of it, by changing only the things that matter and then implementing inside of the library the shims that go from, standard handles to MPitch handles. And it turns out when you do the integration like that, you could take advantage of all the things you know about internal state and optimize the heck out of this, which is exactly what the MPitch implementation does. And as you'll see, has negligible overhead. You could also do a native implementation where you just start from the very beginning with this ABI. That would assume that somebody writes an MPI implementation from scratch. And as I think everybody knows, that's hard. Nobody I know is talking about doing it. We do have a couple of new ones. The Charm++ team has done one. AMPI, CEA has MPC. Those are ground up new ones, but those are huge efforts. And obviously MPitch and OpenMPI and their derivatives are huge projects. I'm not expecting one of these. And as it turns out, there's probably no reason to do it for the ABI purposes. If you want to write a new MPI library, in Rust or C++ because it's cool, more power to you. But the integrated approach to ABI, which does seem the likely path both for MPitch and OpenMPI, works wonderfully. So this is performance numbers on a very small computer that doesn't matter. It's an Intel Tiger Lake desktop, because the point is it's a software overhead. This is a shared memory message rate test. This takes as much protocol and as much network out of the way and just says, how many cycles are we spending doing this? So we've got MPitch with UCX that I built from source, and then Intel MPI, which sits on top of OFI, and the performance gap you see between the first 2 blocks has to do with OFI versus UCX shared memory performance and nothing else. But you see here, if you add Mukautova, which you can read on GitHub, this is my ABI shim for going from a prototype of the standard ABI. It's not exactly matched anymore because I got busy. But basically doing an ABI shim, you take, what's that, about 1% overhead, maybe more, with MPitch UCX. When you're running faster, you notice the software overhead a little more. The important thing here is the MPitch dev UCX with and without the ABI. And those numbers are statistically identical. That's noise. So what that means is what we built that has the ABI versus not, they're the same. And I've read the code. The amount of software overhead that exists in that shim is, worst case scenario, you might take an extra 12 branches if you hit the absolute last else if. You can even optimize that even further if you want. But worst case, it's a couple branches on a couple of code paths. Most of the time, it's probably going to be nothing, and certainly not anything you're going to see on a modern CPU with all the branch smarts and whatnot. So when will this happen? So we are targeting an MPI 4.2 single feature ABI only release next year. This is a very short timeline. The reason is a lot of people want this. We want to get it out as soon as possible. Why are we doing it as an ABI only release? It touches, in theory, every aspect of the standard. We don't want to be iterating in 2 dimensions at once. As soon as the ABI is standardized, ratified, there will be implementations. Mukautova will do it immediately. MPitch will presumably do it immediately, as they have always done with standard releases. OpenMPI has given no firm commitment, but their people are well aware, and they've said that they're very interested in doing something similar. So we can expect to see this stuff. as you know, the diffusion from upstream to releases to packaging takes a little while. But if there's enough demand, I would expect the ecosystem to diffuse rapidly. Finally, in the last minute, I'll say launchers are not part of the ABI, but it's a non-problem because everybody supports all the HPC launchers already. And there's a fairly easy way to just put the smarts into MPI run to make sure the binary lines up with what it loads. Wrapper scripts, not standard. The ecosystem people will figure that out. And for anyone who's concerned, who doesn't like this ABI, MPitch and OpenMPI will obviously support their existing ABIs for as long as there are customers who demand that, whether those be downstream implementations or end users, they'll just provide the shims. Both of them have said that they'll just provide 2 different builds, one for the ABI standard and one for not, for their own ABI. And that's, you build twice, but that's a burden that the implementations can bear much more easily than all of the users of MPI. So that's it. Any questions?
Thank you, Jeff, for sharing your wisdom on this great initiative. So we have a room for some questions. Do we have any from the audience? Jeff, I had a question regarding one of the points that you mentioned about the benefits of standardizing the ABI. So you said like one of these points was getting nice error messages if somebody, let's say, swapped an MPI any source with an MPI any tag. So if one goes for the DL open approach, for the integrated approach like MPitch did, will this still be possible? Isn't it going to be dependent on the implementation that they output these nice error messages?
Yes. I mean, error detection and error messages have always and will always be a quality of implementation issue. Some implementations will, in some limits will just segfault. That's undesirable and rare. You're absolutely right. I do not know enough about the MPitch error message code to know how hard it would be for them to implement that idea. The good news is you can actually do it as a tool. You could do LD, you could do, like LD preload magic error messages and stick something in front of it if you wanted to, because one thing I'll tell you, having measured message rate and some other things, is the error message code path is actually measurable relative to the ABI overhead in some calls. So there may be people who say, yeah, I'm just not going to implement all that error message stuff, but I'm certainly interested in implementing it in Makatava. And then, it can be available as a third-party tool for somebody who's really worried about why their code isn't working.
Thank you. We have one more question.
Hi, Jeff. Do you have any plans to, the MPIT has 3 kind of interface, PVAR, CVAR, and now the events. So do you have any plans to bring them as a standardized way to be shown on the tools or other interfaces?
I have been busy enough with just the MPI API that I have not touched those things yet. That doesn't mean that they won't or can't be part of this. They just, I guess I'll just say they won't be part of the first ticket. Because I have no expertise on that topic, unless doing the ABI work there is an absolutely trivial extension to everything I've done, I can't do it by myself. I'm on good terms with the tools people, and they like this stuff. So my hope is that the tools working group will be able to provide the appropriate expertise to make that possible. But I confess I have 0 on that topic.
Okay, that's fine.
Yeah, one more question.
Hi, I'm a container person, so a little sad to hear that the person writing it doesn't care about containers, but that's okay. Since you don't, are you partnering with anyone from Singulator, or Aptainer, Docker, or Podman to get some performance results for this? I'm very, very interested to see where this plays out, and so.
Yeah, okay. And I sorry, I was being a little cheeky. I care about them in the way that like I care about people who are different than me. So I have presented to CJ Newburn's Container Advisory Council, and I have no idea where that is in the organizational universe, other than it was a bunch of people who do like lead container initiatives at various places. And they were very excited about this. As far as performance, I would love to know what you're interested in seeing. I will pursue that and try to connect the right people to do those measurements. I will say, in fact, almost all the NVIDIA HPC work that happens on the Saline supercomputer is done with containers. So like I do care in the sense that it is fundamental to our HPC business engineering. And there are people who can measure that. I'm just an old person who doesn't use that stuff, so I can't do it myself.
Yeah, let's give a hearty thank for our speaker. So our next talk is going to be remote. Just a little bit of a switching overhead.